fair data practices and data repositories coming more and more into common use. And we have things like software citations and increased impetus to share code as part of publications, which are all really positive steps and help scientific progress and the ability to reuse previous work. But scientific communication today, unfortunately, still looks a lot like this. So even though we make all this tremendous effort to provide computational resources software, at the end of the day, people are still faced with building PDFs for their end scientific article. And that's really a huge shame for all that work and effort to be directed down into a PDF, which is a format that can't be interactive. It's difficult to access and read in any machine-readable way. In fact, we spend a lot of time doing machine learning to get the information out of PDFs while we still put information into PDFs. And really, this could just be so much better. Another real pain point is the fact that a huge amount of time is spent formatting research papers and meeting requirements of different journals. So a huge amount of time that should be spent on science and research is being spent messing around with LaTeX and layout and typesetting in order to sort of satisfy publishers. And although a lot of publishers, some of the larger publishing houses, have web development teams and can create lovely HTML websites, but that's not the norm. And especially if you're a smaller journal and then want to start an open access journal, you don't have the ability to get the web development resources in order to make that possible. So PDFs are, unfortunately, still a part of science communication. But this should be so much better. And so what if we did something different? What if we used the web and be able to provide any scientific article like this where we can have browsable links? We're just using HTML in the web to allow us to maintain context while we're reading, to go through different research references and citations, and even include interactive graphs and widgets and pieces of data in that. Also, what if we go a step further beyond that interactivity and actually embed computation directly in line in our articles? Then we can provide, instead of static figures, we can provide interactive figures with sliders that can be connected to a kernel, connected to data, allowing our readers to explore results and just access another dimension in the work that we've produced. And what if we do that by connecting our writing environment with the environment that we do our computational analysis? Like here in Jupyter Lab, we can write MyST Markdown, and we can blend computation into the narrative of our notebook. So we can add data values that update interactively inside our explanations. We can even include widgets, sliders, graph outputs in line and create a much better narrative experience that is truly interactive. And that's essentially what MyST does. MyST allows you to write once in MyST Markdown in notebooks, and even in fragments of LaTeX can be brought in and converted to MyST. And then you can export to, at the moment, any PDF template. And yes, we're still producing PDFs because people still want the PDFs, but hopefully over time that becomes less important. We have to worry less about the formatting of that, and that's just a method of archival. And what goes alongside that is being able to write once from the same source of MyST Markdown in notebooks. We can also create immediately websites and journals in different formats and immediately create a web accessible, rich version of our work with no extra effort on the part of the researcher. What's more, that isn't spitting out plain HTML, where this isn't a static HTML build. What MyST actually does is translate all the content and all the metadata for your manuscript and your thesis, your report or whatever, into a structured data representation, and that's accessible in JSON or XML, which makes your work immediately machine readable. And this type of publication system allows for aggregation and support a whole bunch of different sort of open and decentralized publication workflows in the future. So that's what MyST is. MyST Markdown is a markup language. It's an official flavor of markup. It's also a specification. That's structured content that you saw is an abstract syntax tree. It's a well-defined specification allowing you to translate and go from Markdown into other languages like LaTeX, Docs, DocX, etc. And MyST is also a tool chain allowing researchers to do this from their own computers. MyST has grown out of the executable books project. And executable books are the stewards of JupyterBook, which is a MyST-based build system to build textbooks from Jupyter Notebooks, and the MyST ecosystem and toolset. That is has multiple contributors, including us at CurveNote, who are core contributors and have been spending a lot of time on the MyST toolchain that I'm about to show. And we go on and also build collaboration and submission systems around this, enabling people to use this stuff to build journals. So, what does MyST Markdown look like? When you're writing in MyST, Markdown is a blend of common mark with restructured text type elements on top. So you can write any common mark, including bits of GitHub flavored Markdown. And then you can add in things like dollar math in order to do inline maths. And as well, you'll notice at the top, there's also a full math equation directive. There are inline roles that allow you to add for here a citation reaching into my bibtec file. You have these things called directives, which are blocks, and there's various directives. This one, for example, is allowing me to include a figure with a caption and deal with alignment and width and other properties, for example, etc. And then cross-references. We overload the basic Markdown cross-reference to allow you to do references to equations, to figures, to sections, to other external resources. And all of that allows you to create a connected document. So you can do what you would reach to LaTeX for, you can do now in Markdown. And that Markdown can be in Markdown files or in Jupyter Notebooks. So there's a lot more to the syntax. Because advise, if you want to look into more, go to mystmd.org and the sandbox. You can just type in there and play around with MyST Markdown, and it'll immediately render because this entire stack is is JavaScript based, so it works on the command line and in the browser equally. So another thing that I showed before on exercises and inline execution and evaluation, etc., is actually an extension for JupyterLab. That allows you to write all of MyST syntax inside of Markdown cells. It'll make MyST the default Markdown editor, and it allows you to do some really funky things, like including widgets in Markdown cells and all sorts of interesting stuff, integrating and leveraging the sort of kernel. Big kudos to Angus and Rowan, who did the majority of work of getting this out there, and especially bringing it onto JupyterLab 4. So that allows you now to be able to author MyST in notebooks, and you can also author your Markdown files in there and also get an article preview. So that extension aims to take JupyterLab towards a first-class authoring environment. So definitely check that out if you're interested in your work in JupyterLab. So one interesting thing that MyST does is it allows you, an important thing is that figure directive I showed, it allows you to put images in, but it also allows you to embed notebook outputs directly. That means you can write an article, have multiple notebooks doing your work and producing figures, and that appears directly in the scientific article. And as you work, update your notebooks, rerun the kernel, your figures all automatically update and stay linked, cutting out sort of fig save and having to figure out and version control your artifacts separately. So we'll do a little bit quick demo to see what a MyST Markdown project looks like. So here's an example paper, my Volcano paper, and I've got a bunch of stuff in the folder, for example, some local data files, some static images. I've got my notebooks that I'm still working on, and I've got a draft of my paper here. I also have some references, and I'm doing some dependency management because I'm working in notebooks and computing stuff. Whoa. So then starting a MyST project is as simple as typing MyST on the command line. The command line tools are very verbose, aimed to help you. And when you do that, it basically writes a configuration file. It'll ask if you want to start a web server. And when it does, it downloads the default web theme, builds all your content, and then you're able to go off and look at that site in a web folder, sorry, in a web browser. And this is what that looks like. This is rendered. This is a Markdown file rendered with the MyST article theme. It has all of the hover tooltips, cross-referencing, etc., that we've seen in some of the videos so far. And it also has this figure, which was created in my visualization and figure creation notebook, which is also there included in the build. So immediately and very easily, I've got this rich website showing my notebooks and my manuscript, and just it's all organized in terms of a manuscript and its supporting documents. This is a PNG file with matplotlib to create this figure, but of course I can have a number of interactive things in there. Plotly plots, Altair works well and remains embedded, so you can already start building interactive elements into your paper and website. So that was quite a rich looking paper there, and actually I've cheated a little bit because to get to this stage needs a little bit more configuration, and I'll go through that now to show you how I got all my author information in here, how I got my PDF, and how I got these things called JATs and Mecha. What's interesting here is MyST allows you to produce the exact assets that major publishers use for archiving and distribution of final articles. So now you, as an author, or somebody who wants to build a journal, has got all the tools and resources to be able to meet those sort of ISO specifications of how these articles are preserved and communicated. Cool. So when I ran MyST, all I did was add a build folder, which generally we can just ignore, lots of temporary files in there, and a MyST configuration. And this MyST configuration file allows me to start adding lots of the metadata that I need for my publication. So we can add authors and affiliations into that section, things like title, subtitle, subject, author IDs, contributor, emails, roles via the credit contributor roles system is also supported. And that starts decorating the title block in here, for example. We can add license and metadata for both content and code, do things like add open access badges, link to repos, etc. And we can also start defining which sort of export formats we want. If we're gearing this up for a submission to like a journal, we'd want to add Mecha and JATs so that the publishing assets are available. But also we specify what PDF we want, pick a template, and specify some details. And then those things are all available in the final build as well. So by doing that configuration in MyST YAML, I was able to go and just finish off the population of my publication. Cool. So you can still build PDFs, and building PDFs is pretty easy. MyST has an online template repository with community contributed templates. You can type MyST templates list, and you'll get a list of all the current templates back. I think there's 400 plus journals supported by 13 templates here at the moment. And again, the API is verbose, and it lets you helps you out with the requirements needed for each journal. For example, if a data availability statement is needed, whether a paragraph on funding's needed. MyST tries to surface all of these things, and it makes it very easy to create that PDF you might need for submission. And then you can create the article, provided you've got LaTeX installed, and then you have a PDF in the format that you need on the template without touching any of your original content and without having to mess around with typesetting or layout. Cool. Next slide. Okay. So as well, in terms of deploying to the web, you can tell MyST to give you a static pile of HTML if you want. Otherwise, you can host your website on your own on GitHub Pages. If you just type MyST in the GitHub Pages, it will ask you a couple of questions, and then it will write the GitHub action for you that you need to run the build and publish to GitHub Pages on CI. You can also do the same using a Curve Note hosting service as well if you want to host your site that way outside of GitHub Pages. And again, this just sets up the GitHub actions for you. And it just aims at taking the complexity out of having to do all this configuration so you can concentrate on authoring. So MyST is sort of built for modern scientific publishing, and there's lots of ways to use it for blogs, for research and lab group sort of websites for self-publishing. But also what we're doing is building journal systems around these. And the first ever MyST journal system was the Physiome project, which is a life sciences project. And this is completely built on MyST. And submissions are taken here and actually in LaTeX and converted to MyST and then added to the journal in a quite simplified and highly automated sort of submission process. Cool. So a bit about thebe. So thebe is a headless connector library for Jupyter. It's quite an opinionated piece of code. The thebe library has been around for a while, and it does quite a lot of things. Recently, we've split it out into separate modules to make it more accessible to MyST and other web apps. And I'll show a bit of that now. And what we've done is we've used thebe to tightly integrate Jupyter into the MyST theme. Now, if you're just interested in using thebe on your own website, you can pick up the thebe library and add it to a simple static HTML page. This is just a simple static HTML page. So once you load the scripts, once you add, let me refresh, I've already run this. Once you add the scripts and the styles, you add a configuration tab, and you can see here you can connect to Binder, you can connect to a local server, you can connect to JupyterLite. In this case, we're connecting to JupyterLite. There's some default UI you can add, and when I press that button, that has started the JupyterLite server in the browser, and I'll just hit this. And what else it's done is it's taken this code block, which was just a pre-tag, and turned it in now to a full code mirror editor. So this is a complete editor. I can make changes to the code there, run it, etc. And the thing with pyodide, after I hit run, it has to go off and load wheels. But once it does, then we have full like IPy widgets running in the browser, like so. And you're able to add thebe to any web page and get that sort of functionality and connect to JupyterLite. If your dependencies are supported by JupyterLite, you can go that way. If not, you can connect to Binder or a Jupyter Hub or a local server. So that's what thebe does. It takes care of the headless connection to Jupyter. And what we've done is we've taken the MyST website theme and then fully integrated thebe. And what that allows us to do is allows us to now start connecting articles and notebooks to a Jupyter kernel. And this is an example of the second MyST-based journal, which is going to go live in the next couple of weeks. It's Elemental Microscopy by Colin. And these examples that I'm going to show now are actually Colin and Georgios's submission instructions for their new journal. So this is their sort of article template for their authors and what their authors are going to follow. So I'll show some of these examples. And if you think about figures, and in a journal like this, typically this is a typical figure. No, you'd have some screenshots and a multi-patch figure, and you'd be doing some zooming in and using the caption to tell people what is going on. Instead, we add in, and we're just missing a placeholder image here, we add in an interactive figure, and pressing that power button connects to thebe on my local machine. I've got a Jupyter server running. And then immediately, we've got an interactive figure that readers can actually then come along and interact with, and zoom in and pan around and do all the things that you can do with like an IPy widget-powered plot, and now have this more exploratory experience of your paper. And these are good examples. Whether you can fit in here, anything that runs in your Jupyter notebook will render in here. We are rendering a Jupyter Lab output cell without a lot of the decoration. But when you go and craft IPy widgets type outputs, then you can start to get some really effective sort of reader experiences. If I just start this one. Maybe tempted fate. Reaching for the page refresh. Okay. You can then sort of design very custom experiences for your users. And the folks behind this journal are really pushing the idea of right, how do we encourage submissions that are highly interactive and highly engaging and appropriate for the field? So thebe takes care of all that interlinking and interconnecting. And if you want to move from a binder onto thebe-lite in MyST, it's as simple as changing the config. So you just move from my binder settings through to thebe-lite true, and then the exact same site is going to work, but start a thebe-lite kernel. Cool. And again, we're just running out of time, but again, I've got some examples I can show for exactly the same happening in thebe-lite. It's the same example as earlier, but we have the same sort of figures. I'll let that complete and switch back to it. Cool. So if you'd like to find out more, there's docs, demos, and links all up at mystmd.org, as well as a playground where you can go and experiment with MyST syntax. If you're hosting a journal, we'd love to hear from you, because we're helping people set up now small-scale journals based around MyST submission processes, and we're starting to build peer review functionality as well based around that. The aim being a very seamless author experience where you just submit your GitHub repo, and an automated system takes care of the rest of the automation. I think we're quite interesting working with these small journals. Journals are realizing, oh, you're turning us from a journal into a publisher, because a lot of time a small journal would be forced to work with a large publisher in order to have all this infrastructure. But now this can come back down and all be owned and sort of managed by the open access journal themselves. And equally, this is amazing for tutorials, for project communications, etc. There's actually a parallel project called Papyri, which is looking at replacing Sphinx as a build engine for Python documentation. And they are actually they're starting to base their internal representation on MyST. So in the same way, publishing structured content that can be shared between multiple software documentation sites. So MyST can be used to integrate with that too. We do a bunch of webinars going over latest developments and just how-tos and things like that. If you'd like to join one, add an email in there, myst.curve.com, and we'll send an invite the next time we do a webinar. That's everything. Thank you. There's just that JupyterLite plot working now.
Thank you, Steve, for this neat presentation and all these demos. So do we have time for questions? Feel free to ask Steve some questions. And wait for the microphone because it's recorded. Thank you.
My question is, how widespread is the adoption of the templates that you showed among scientific journals?
Not much. No, it's very early days. I'd say, interesting, we've got some stats on MyST, the usage of MyST Markdown. Like 15% of the Python documentation ecosystem is already using, we estimate, MyST Markdown as a flavor, and that's because of Jupyter Books and the Sphinx integration. But on the actual journal side, it's very, very early days. We have a bunch of contributors making contributions to the open source repo, because if you can get anybody's LaTeX template from any journal, we basically use a Ginger templating language to mark up, and then you've got a data-driven template and add that to the repo. So we're looking for contributions there to increase that pool. And on the web side, there's only 2 web themes at the moment. And we need a bit more refactoring work, I think, before we proliferate that. We're still getting a tight common base. There's a question.
Yes, Sik, you can.
Okay, so do you think we'll ever see the mystic dialect of Markdown in things like GitHub or GitLab or those places? And do you have a roadmap on how to get there? Thanks.
Could you repeat? Sorry.
To have like the Misty Markdown in places like GitHub.
Yeah, we don't have a roadmap for that. Do you mean actually sort of convincing GitHub to support MyST Markdown?
So that my README can have all that stuff.
Yeah, we'd love to, but we haven't started any of those conversations. If you know people who are open to that, I'd love to chat. The other way around, MyST is built to be as permissive as possible, so it accepts GitHub and various other works and flavors of Markdown, but pushing it out to GitHub is a challenge, I think.
Yeah, I have a lot of co-authors who don't know how to use Git or whatever. They usually write in Word. So is there something like, for example, Overleaf, where I could like direct them to that helps them getting started with writing Markdown and collaborating basically on a MyST paper?
Yeah, there's a couple of different ways. Before we got into the journal side, that's what CurveNote tried to do. So we have like a WYSIWYG online editor that will produce MyST projects. So that's one way to collaborate. The other way is because MyST's the abstract tree is pretty solid. There's now a bunch of interchange libraries, so you can easily get out to docx, email it over, get it back. And docx to MyST isn't in there yet, but there's a lot of requests for that. So you can now start thinking about MyST also a little bit like an opinionated pandoc, where you can do conversions to support other contributors. But other than that, then like CurveNote's the only other editor. Teach them Git. Yeah. Yeah.
Do we have one more question? Yes, Joris.
You briefly showed JupyterLab MyST integration.
Yeah.
Do you have any idea how it would be likely if JupyterLab would natively support MyST, or at least for basic rendering, maybe not all the fancy interactive things, but...
Yeah. I mean, it could. I think there's a lot of discussion at the moment, and there's active discussions on the overall notebook format and the next step it should take. There's discussions in JupyterLab around Markdown isn't actually defined there. There is no way to describe the current support in JupyterLab. It's just some Markdown compact plus. So there's that all discussion going on. Plus, Executable Books is an organization that was originally funded by Sloan, and that grant's come to an end. So possible future home for MyST could be as a Jupyter project, and I think that would like help with getting it more tightly integrated into the stack too. So that's all possible.
Thank you very much, Steve. Thank you for your questions.
Thank you.